Hello everyone, today I'm going to show you how to design steel structure, steel warehouse from the material input to the final design of the steel structure, and also the connection design as well. So first I'm going to show you the material. So you have to go to tools and job preferences, and keep in mind that for this tutorial I follow the AISC standard, or the American standard for steel design. So everything is American standard, like load or the connection. So just keep in mind that I use the American standard in this tutorial. So you have to go to the job preferences and materials, and you can choose the material any country. It doesn't matter, because I will modify this again later, but you can choose the country first just to have the default value in the basic set here. So in order to modify this, you click the modification button, and next you can change the steel by go to the steel tab here, and you can name the steel material that you want to use. So something like S235 or SS400 is the same. So the characteristic, or you can say that this is the yield strength. It's 255 or 245. It depends on your materials standard. So you just put the material in this window, and then you click add and OK. But I already add this, so I'm going to click cancel, and I will use the S255. The yield strength is 235 megapascal, and for concrete and other materials is not relevant for this video, so I'm not going to cover this. You can also change the dimension here. I use something like this because it's already familiar with me, so I will use something like 3 digit after the decimal point. And you can also check the design codes here. So this is for steel and aluminum structures. So I use the AISC 36016, and again the other setting is not relevant in this video, so I just keep this default here. And you can also check the loads. This is for the load combination. It's following the American standard ASCE, and this is for snow and wind loads, but we're not going to use this. We will use the wind simulation. So I just keep this default as well. You can check the structural analysis, but for this video I'm going to keep the default because it's already enough. And it's done for the job preferences, so I'll click OK. And if you have something to change more, you can go to preferences here, like languages. So the regional setting I use is United States, and you can choose Eurocode as well if you prefer the Eurocode. And you also can change the layout, color, like the background here. If you prefer that, you can change it as well, but I'm going to keep it like this, so I click cancel. Now the first thing that you need to do is create a grid line. So I click on the axis definition here. You can also go to geometry and axis definition. It's the same tool. Now for the steel warehouse, I'm going to assume that the span is 30 meters. So I want 30 meters divided into 5 meters, so it's going to be 6 of 5 meter, so it's 30 meter. I want to use ABC here, and for the base spacing, I think I will use the spacing I want to use is 6 meter, and let's say 12, so it's going to be 72 meter. And I will keep this numbering 1 2 3. And for the elevation, let's say the height, the eave height, or the low the side height of the warehouse is 8 meter, and I will use this as value, so we will show the level here. And let's say it's the top roof is 1.5 meter. Now I click apply, and this is our grid. I think 1.5 is too small, so I'm going to change this. We delete this first. Now we change it to 2.5, and we got our grid. So now, in order to model the steel warehouse, you need to create the cross sections first. So this is the default cross section. We're not going to use this, so I will click on the scissor button here. So click yes. We will delete all the section that are not used in the modeling here. Now I create a new section. So first you choose the section type as steel, and this is the material for the mainframe. I will keep this. And for a warehouse, mostly we use the build up section, so I'm going to use the eye symmetry here. So let's say 3. Okay, I will name this as C1. Now this is the web thickness, and this is both of the flank thickness. So this is just the initial section, so I'm not expected to think that, to get the section here to pass the steel design. So I just put this as the initial section. So if this section is not passed, I will change it later. But for now we use this. So I click add and it will create one section here. So now I will create the beam. Let's say B1. I will use the same number, the same value here. So we click add. So this section is for our end frame of the warehouse. Now I will create the section for the main frame. So the main frame is the span is 30 meters, so it's not small. So we cannot use I mean we can, but it's not economical to use the eye symmetry here or the parametric section like this. We need to use the temper section because it's more economical. Now we are call it C2, and the flank side here I will use something like 200, and this two is the same, but for this one I want to use 300 and this is 800. So it will vary from 300 millimeter to 800 millimeter, and the thickness I use the same thickness as C1 here, but I'm not expecting this section to pass the design. Now for the rafter or the beam, we call this E2. I will change this to 800 and this is 500 because it varies from big to small. You will know when I model the warehouse in the window here. Now we create one more section. It's called B3 and this one is 500. I will show you where the B3 located. Now I will model the beam and column in the on the grid line here. So first you can click on the bars here and you can choose the type, the bar type, something like a column or beam, but I will keep it as the simple bar. It doesn't matter for now, but when we go to steel design here we will change this bar type later. So I just keep the bar type as simple bar like this for now. Okay, so I will draw the C2 first. So I click on the beginning point here, I click on this, and the end point is this. Now I click on this again, and this. I will show you the section by clicking on this button. So as you can see, the section is vary from 300 to 800 like this. Now I will draw the beam. So in order to easy to draw, you can change the view here by go to 8Z and change this to the structural axis 2, and this is our frame. Now I will choose the section here as B1, and I click on the beginning point here, and this is the end point. Again, so I think something wrong with the B1 here, so I'm going to close this, and I will check the section here. Okay, it's not wrong, but I choose the wrong section. It should be B2. So I'm going to change this. I will click on the node here and apply. So this is our section B2. I don't want the section to vary from this point to this point. I only want it to be vary from this point to something like this. So I will divide this beam into two. Now you can click on the edit here. I will put it on the space here. Now in order to divide the beam, you need to click on the division button here. So you can divide the beam into end parts or in distance, or you can choose this option or by your plan. Now I will choose in distance, and I want something like 6 meter. And if you select this, the beam will not divide it into two, but it will generate the internal load at the 6 meter from the start point where you select the beam. So I will show you this. Now we click on this part. As you can see, the arrow here indicate the start point from this point to this point. So the node, internal node on the beam will locate at the 6 meter from this point. So it should be something like on here, I think. So I'm going to click this. Now in order to know where is the node, you can click on this. This will show you the number of the node. So this is our new node, but I don't want something like this. I'm going to select the node here, and if you select the node, the information here will show you that one node is selected. Now I'm going to click delete, so this node is disappear. Now I will divide again, but this time I will deselect this, and I will keep 6 meter like this, and I click on this part of the beam again, and this is how you divide the beam. So I will divide this one also. Now we change section this and this into V2. Now I will select this two as B2. Sorry. And this is the B3. Okay, now I will hide the number of the node first, the label of the node. And you want to show you if you want to show the bar number, you can click on this button. So this is the bar numbers. So now you got the mainframe, and what you need to do, it's easy. You just need to select this section and go to translation. You can copy or move, but in this case I will copy it. I will not put the number here, but I will change 1 here into the number of the mainframe in our so the warehouse here. So as you can see, there is something like 11 mainframe, but we already got one mainframe here, so this one should be 10. And for this number, you can import manually import number. One more way is you can click on the first point here and then the next point here, so it will generate the mainframe like this. Now you got the mainframe of the warehouse. Next, I'm going to I'm going to draw the end frame. This can use the same method. First, you change the view and then go to the axis that you want to draw. Now I will draw the C1. This is C1 as well, and this is B1. Next, the C1 again, but in the middle part here. I'm going to draw until the top here. Now I will cut the top of the column. You can click on the trim button here. So first you need to select the cutting objects. So I will choose this beam and this beam. And this is the trim object, so you need to choose which object that you want, but you have to choose the part. If you click on this part will disappear. If you click on the top here, the top part is will be disappear. So I will click on this and this. So this is our mainframe. Now I don't want this column to be like this. I want to rotate it, let's say 90 degree. So I click on the geometry here and properties and go to gamma angle, and I choose the special values here to 90 degree. You can select the bar that you want to rotate and put it in the list here of the box here, but you can also click on the column that you want to rotate, and it will automatically rotate 90 degree like this. So we click on this also, and this one as well. So this is how you draw the end frame. I will copy this. I will use the same method as we copy the main frame, but this time you need only one, so I will not change this, and I click on this. Then this is our steel warehouse. Now next you need to draw the girth and purlins. So I will create another sections. So click on the new button here, and for the purlin I will use I think I will show you the user input section here as well. So now I will close this first. I will open the AutoCAD. If you want to import a customized section or user section, you can use the import section import option from AutoCAD. So now I will create a new section. I want to use a Z section, so I'm going to draw a polyline. Now let's say this is 25. No, I don't want like this. I will delete it again. I want this 25 and it's rotate 45 degree, and this is 25, and this one is, let's say, 200, and this. Okay, now I need to do is move this section to the center here. So I will create a line, and the first point is 0, 0, and I move the section to here, and I will delete this. So now this is our section. So now I'm going to save this to desktop. Let's say Z. I will change this into this tab and save. Now we close this first. So in order to import the section from AutoCAD file, you can go to Tool and Section Definition. Next, you need to select the thin wall. So click on the new thin wall section. This will change to thin wall. And next, you need to import the XF to the robot structural analysis here. So I will click on desktop and this file that we just saved, and I will keep this as default. I click OK, and this section is now in the robot structural analysis, but we need to change the thickness as well. So I will click on this and right click and go to properties, and I keep this as still. We're not going to design the thin wall here because this is the core form section, and the robot structural analysis does not support the design of the core form section following the American standard. So I will model this section, but I will not design this section here. So I will click on the thickness and change it to 1.5 and apply. We click OK, and in order to make sure, you can just right click again and go to properties, and this one is 1.5. Now in order to import it to our model, we need to save first. So you can click on this button, save to database. So you can choose the database here. I will choose the user here, and I will name this like purlin, or you can just say P, and this is also the name. You just input like something like 200, just to know what type of section is this. Now I click OK. Next I will go to start here, and we check the section. So I will go to this standard and user and go to, so there is no section that we create yet, so we click this and open the new section again. So this is now imported. So we click on this P and this is our section, and this is the MI angle of the section because it's not symmetry. So it's we are going to have a little number here. Now the material, like I said, we're not going to design this, so I'm going to put this as steel, and we click on add. This is our section. And now you can draw the purlin in our model here. So I use the same method. I keep it as the simple bar type as well, and I will draw from, let's say, 3 meter from the bottom of the column. So I'm going to create an internal load at from 3 meter from the beginning point of the column here. So I click on the distance and change this to 3, and I select this. Now we click on this column, close it. I will open or show the node number here, and this is our node. The column is not divided, by the way. So now I click on this. So this is our gut. You can rotate this as well. I go to gamma angle here and rotate this 90 degrees. And next you can copy this. Now I will select this and let's copy it for something like, let's say, 1.3 meter and copy. So this is what it copy. You can do it again, and this is exit our column height. So I'm going to delete this, but keep in mind that the node is still there here. So in order to delete this, you can select and delete, or one more way, you can select by clicking the right click on the node here and select all, and then you can click the delete button on your keyboard and this window will appear. So what you need to do is select no, delete only the selected bars, so apply, and the node here is now disappear. Next I'm going to draw the purlin. So first I need to change the coordinate system here into this plane. So I use a local system definition here. First you click the first point, second point, and then third point. So now I will click on this one, and this one. So it will it created a new window here as view 1, and this is the original view. This is the view 1, and now the global coordinate system is changed. I will draw this purlin to show you how it was changed. So we click on this point. Now I will go to the view here and show the front. So as you can see, the beam is not at the 0 gamma angle like before. It's rotate a little bit. It rotation is follow our plan that we just created in view 1 here. Now I will copy this first. So I'll select this and choose this translation again. And now I will change the number of the y here. So first is 0 and then y and then z. So I want it to translate 1.3 meter in y direction. So we copy this as execute. I will put this number like 8. Now let's say 2. I think if we create one more, if the purlin will exit the bar length, so I will keep the purlin like this. Now in order to copy this purlin and girth into another side, you can use the vertical mirror here. And first you need to check the plane here, and our plane is YZ. So sorry, we cannot use this in the view one here. So I click on the exit here to close the view one. Now this is this purlin and girth are selected. I will go to vertical mirror again, and our plane is Y and Z, as you can see here. So all you need to do is just click on the point where you want the reference line or plane located. So this is the point. I click on this, and it will mirror the purlin and girth automatically like this. So now you got the purlin and girth, but now it's not done yet. You need to copy this, so I will select all of this section and go to translation again, and this time we'll change this into something like 11 because we already have one. Now we need to click on the beginning point and the end point of the translation. So this is how you got the purlin and girth. Next we need to draw the purlin at the end frame as well. So we click on this and click on the beginning point. Now I will choose drag here. Again, beginning point, end point, end point, end point. This is as well, this is as well. Next I'm going to select the girth at the end frame here and rotate this 90 degree, and I will select this again and do the translation again, but now this time is Z, so I'm going to change Z to 1.3 and copy it, and next I will copy this beam and this beam to the point here, but I don't want this at that point, so I'm going to deselect the 4 beam inside here. Now copy this. Now I select this and change this 1.3 and copy, and then I select the 2 bar here and copy. Now I will select this girth and copy it to the other end frame. So you just do the translation. Now we got our our warehouse. This is how you model the warehouse. It's not complete yet for this tutorial, but I will end this for now, and I see you guys in the next video. I will continue this warehouse design. So please subscribe and click on the notification button to get yourself notified when I upload a new video. And thank you for watching. I see you guys in the next video.